Okay, so for this deep dive, you've given us quite a stack of stuff to go through.
Yeah.
And it looks like it's all about
It is.
machine guarding.
Yeah, custom machine guarding.
Custom machine guarding across, looks like tons of different industries, just a really
a real variety.
a huge variety.
Yeah.
So I guess what we're trying to do today is sort through all of this
Yeah.
and figure out what are the most important things to pull out,
Right.
what are the core principles behind all of this guarding, and how do they actually put it into practice,
Exactly.
and what are the kinds of solutions that they have.
Yeah, and what are the common dangers they're trying to prevent?
Yeah. And
Right.
what's the goal?
A lot of it boils down to what are the dangers?
Yeah, yeah. So we want to sort of give our listeners a sort of fast track,
A shortcut.
a shortcut
Yeah.
into what's important here, so that they don't have to go through all of this themselves.
Yeah.
Sound good?
Sounds
Okay, so right off the bat, it just strikes me how different these solutions are depending on
absolutely.
what industry we're talking about.
Yeah, you can't have just like a one-size-fits-all approach to machine guarding. If you think about the hazards you'd see in like film packaging versus like mining, they're completely...
Totally different.
Yeah, totally different.
Yeah, so PowerSafe Automation here is, they're really outlining a very specific or tailored approach
Very tailored approach.
to each one of these
Absolutely.
sectors.
Yeah.
So why don't we jump into a couple of these?
Yeah, let's do it.
First on our list here
Okay.
is film packaging equipment, which I think we all have some sense of what that is, but it's things like slitters, doctors, rewinders.
Rewinders, yeah. Turret unwinders.
Turret unwinders, continuous winders, duplex slitters.
Lots of winding going on.
Lots of winding going on.
Yeah.
Flame laminators, cold nip roll coaters.
Lots of rollers.
Lots of rollers.
Mm-hmm.
Sounds like a lot of moving parts, a lot of potentially dangerous things.
Yeah, absolutely. So
in this industry, what are the main...
Yeah, the main hazards you'll see in this kind of machinery have to do with, well, first of all, wrap points. So that's any point where you have like the flexible material wrapping around a rotating part.
Gotcha.
So like a roller, that's a really common one.
Yeah.
And then in-running nip points. So those are created when you have like two rollers coming together. Or a roller and like a stationary part. And basically it's just a pinch point where you can get something drawn in.
Got it.
And then, of course, cut points if there's any blades involved for like slitting the film.
Okay.
Crush points from any heavy moving parts of the machinery.
Yeah, that makes sense.
Yeah.
Those are your...
So what do they use
big ones
to guard against that?
Well, they talk about using polycarbonate guarding.
Yeah.
Which makes sense.
Yeah.
Because you want to be able to see...
You do. It's transparent, so...
See what's happening.
Yeah, polycarbonate is a good choice, but it also provides a barrier.
Yeah.
So polycarbonate, safety switches, safety laser scanners, enabling switches with emergency stops, pneumatic controls with location sensors.
So lots of different ways.
Yeah, so it's really layered.
Yeah, to make sure
a layered approach to safety.
that nothing bad is happening.
Absolutely. So those polycarbonate guards, they let the operator see what's happening because with film, often that's really important to be able to monitor what's going on.
Yeah.
But then you've got these safety switches and the laser scanners, which act as interlocks. So they will automatically shut down the machine if the guard is opened or if someone steps into a dangerous area. Those enabling switches with emergency stops, those give even more control for tasks where the operator might have to be closer to the machine, but they've got that emergency stop right there. And then pneumatic controls, they're all about making sure that the machine's in the right position before it starts running.
Got it.
So they use location sensors for that.
Okay, so it's really about making sure the thing's in the right place before.
Yeah, and that's common with pneumatic systems, you know, to have those kinds of controls.
Yeah. Okay, so
with film packaging, it's a really interesting balance between needing to see what's going on and needing to be protected.
Okay, so let's switch gears completely to corrugated box manufacturing.
All right.
So this one...
this one's got some...
It makes a distinction between
it's an interesting distinction.
wet mill equipment and paper mill equipment.
Right. So you've got the wet end of the process and the dry end of the process.
So what's it...
And the hazards are going to be a little different.
What's the main difference there in terms of safety?
Well, the environments themselves are different.
Yeah.
You're dealing with, like the wet mill is where you have the raw pulp and the water.
So you've got separators, evaporators, wet lap machines, splitters, all that kind of stuff.
Okay.
And then in the paper mill, that's where you've got the already formed paper.
Yeah.
And you're doing things like slitting, rolling, printing, all that.
So the materials are quite different at that point.
Still similar.
Yeah.
But the way you approach them is different.
Yeah.
So you're still going to see things like crush and cut points, wrap points, in-running nips.
Yeah, all the stuff we talked about before.
Yeah, but you're going to see, for example, in the wet mill environment,
okay,
a bigger emphasis on intrinsically safe.
Right.
Safety switches.
So intrinsically safe, what's that all about?
Those are switches that are designed to prevent any sparks or electrical faults that could ignite flammable materials, which you're more likely to encounter in a wet environment.
Yeah, where they're not amplifying any electrical hazards.
Right. So that makes a lot of sense.
Yeah.
And specifically for corrugated box, they mentioned nip guards, laser scanners.
Right.
And what they call a dead man.
Yeah, a dead man enabling switch.
Yeah. And that sounds like a lot of focus on those pinch point hazards.
It is.
So those nip guards, are those just like barriers?
Yeah, nip guards are physical barriers.
Okay.
Positioned right at the in-running nip point.
Okay.
To prevent anything from getting
pulled in there.
And then laser scanners.
Again, those are like area monitoring, right? So they can detect when something's in a certain area and trigger a stop.
Yeah.
And dead man switches, those are interesting.
Yeah, I'm not sure I've ever heard of that. Explain how that one works.
So a dead man switch
requires
constant pressure
from
the operator to keep the machine running.
Yeah.
So if they let go, the machine
stops.
Oh,
so it's like a constant open.
So it's used when you absolutely need the operator to be in a potentially dangerous zone.
Yeah.
So like if they were to lose consciousness or lose control, the machine would stop.
Right. Okay, that makes sense.
So it's an extra layer of protection.
Got it.
Air-operated controls, we see those here too.
Yeah.
That's where you're using air pressure to control certain functions, which can reduce the risk of electrical hazards, especially in those wet environments.
So this one, corrugated box, the main takeaway here is that it needs a very specific approach.
A nuanced approach.
Because of those two different environments.
Yeah.
Right. Wet versus dry.
Even though some of the hazards might be similar, you need different strategies.
Exactly.
To mitigate them.
Yeah.
Okay, let's move on to something else.
Okay.
This one is called industrial motion machines.
Okay.
Which I think are really...
These are the workhorses of...
Yeah, the workhorses of...
Manufacturing.
So we're talking about things like...
planers, hobbers, shapers, milling machines.
Planers, hobbers,
broaches,
lathes,
flame hardening.
Yeah, all the really sort of classic...
classic machinery.
Machines. And they mention here that a lot of these predate...
Oh, absolutely.
A lot of
these are from before.
Modern safety regulations.
Yeah, they didn't really think about safety as much back in the day when these were designed.
So what's the challenge when it comes to guarding these older machines?
Well, because they weren't designed with safety in mind.
Right.
They often have a lot more exposed moving parts.
Yeah.
They require more direct interaction.
Gotcha.
From the operator.
Yeah.
And they might not have those integrated safety features that you would see in a modern piece of equipment. And they mention here that, getting a 100% safe environment might not be feasible with some of these older machines.
Right.
So you're really focusing on mitigating.
Yeah, just the worst.
The worst hazards.
The hazards.
Yeah. So things like entanglement, crush points, trapping hazards.
And the ways they go about guarding these sound like they reflect the focus on just sort of...
So perimeter guarding, right?
Perimeter guarding.
Keeping people away.
Yeah.
Locking safety switches.
Okay.
With speed monitoring.
Okay, so that sounds like...
So the machine has to be...
The machine's got to be completely stopped.
Completely stopped before you can... even guard.
Open it up.
Yeah.
So why is that speed monitoring so important, do you think?
Well, it's adding another layer of safety, right?
Yeah.
It's not just relying on the guard being closed, but it's actually... verifying that the dangerous motion has completely stopped before you can open it.
Right. Yeah.
So it prevents someone from reaching in when something's still
moving,
spinning. Yeah, that makes sense.
You see pneumatic and hydraulic safety valves here.
Yeah.
Which are all about controlling the power sources.
Making sure they can be safely de-energized.
Right.
And then 2 hand controls.
Right.
That's a classic.
Yeah, I've seen those before.
Yeah, that's where you need both hands to activate the machine.
Keep your hands out of the...
Keeps your hands out of the danger zone.
Right.
You also see on more modern CNC machines, they talk about CNC spin windows.
Oh, okay.
Which allow you to see the cutting process without being exposed
to the hazard.
So that's kind of a newer
Yeah, that's more of a modern
adaptation to those older machines.
Right.
Okay, let's move on to wire and cable.
Okay, wire and cable.
Which,
So now we're talking about
sounds like
some heavy-duty
armoring machines.
Machinery.
Yeah. Drawing equipment.
And they mentioned here again that a lot of the older machines...
Oh, yeah. Older machines in this industry
didn't really have operator safety.
Not a big focus.
In mind when they built them.
Not at all.
So what kinds of hazards?
So you see a lot of exposed...
So prevalent.
Rollers, cutting mechanisms.
Back then?
Yeah, high-speed rotating parts. I mean, think about it.
Yeah.
The process of making wire and cable, you're melting.
Yeah.
And forming metal, you're insulating, you're sheathing.
Yeah.
There's a lot of
That's dangerous.
potential for things to go wrong.
Yeah.
So now they're focusing on reducing hazard, like crushing points, friction, abrasion from those materials.
Gotcha.
Entanglement in moving parts.
Yeah.
And they're even talking about ergonomics and tripping hazards just in the general.
So it's not just the machines, the whole environment around them.
Right.
Yeah. Okay, so now they're using...
So now you see them using things like steel guarding.
Steel guarding.
For those really strong physical barriers.
Yeah.
Zero speed safety interlock switches.
Yeah.
Again, making sure everything's completely stopped.
Yeah, that keeps coming up.
Yeah.
Again and again.
And then ballistic guards, which are...
Ballistic guards, what's that about?
Those are interesting. Those are probably used in specific applications where there's a chance of ejected parts.
So like,
if there was a wire break or some kind of malfunction that sent material flying.
Yeah, gotcha.
You'd want that kind of protection. Yeah. Protective ballers and guardrails. Yeah. Those are just physical barriers to keep people away from machinery. Yeah. Or to define safe walkways.
Gotcha.
And then safety light curtains.
Right.
Those act as non-physical barriers, so they're light beams.
Yeah.
And if you break the beam, it triggers a stop.
Yeah. Yeah, I've seen those.
So it's a really interesting trend towards comprehensive protection.
Not just focusing on those primary hazards, but also the...
Secondary risks.
Secondary risks and the whole...
And the environment.
Environment.
Yeah.
Okay, insulation manufacturing.
Okay, insulation.
This one...
so this one's interesting.
It divides it up into a hot end and a cold end.
Yeah, the hot end and the cold end.
So what makes safety different?
So the hot end is where you're dealing with really high temperatures. You've got furnaces, spinner decks, that kind of thing.
Okay.
Cold end is where you're cutting, shaping, conveying the finished insulation. So you've got saws, slitters, choppers, facing pits, conveyors, all that.
So it's the same material, but in very different stages of processing.
Right. And what they really highlight here is that they need some creative solutions.
Cool,
because you don't want to have to be constantly shutting things down.
Yeah, because that would really slow things down.
Imagine trying to do maintenance in a dusty, fibrous environment. Yeah. Having to go through a lockout, tagout every time.
Right, right.
That would be a huge pain.
So they're looking at things like...
They're using things like air knives.
Air knife.
No touch tools.
No touch tools.
Regulatory mesh openings.
Okay, what's a regulatory mesh opening?
Those are mesh openings with very specific dimensions designed to prevent access to dangerous areas.
Gotcha.
While still allowing for maybe ventilation or visibility.
So they're big enough to let some things through.
Yeah, or maybe the product itself to pass through.
Big enough to let a hand through.
Yeah, okay, I got it. And the fact that they're using presence sensing devices.
Yeah.
Even in environments with dirt, dust, water, that shows you that they really need reliable technology. And, of course, emergency stops everywhere. Yeah. Easily accessible.
Okay. And then they mentioned some
of the other guarding we see here.
Like bigger picture.
Is things like power transmission covers, which are just, covering up those moving parts. Oh, guards, 3D safety radar systems.
A 3D safety radar, that sounds pretty
Those are interesting.
High-tech.
Emergency rope pulls.
Okay.
Safety guarding.
Trapped key interlocks.
Trapped key interlocks. Safety mats.
So these are kind of different from the more localized.
Yeah, so these are more area-wide.
Area-wide, yeah. So how do those work? Like, what's the benefit?
So the 3D safety radar can detect a person entering a hazardous area even if there's obstructions.
Oh, wow.
So it's like...
So it can see around corners?
Yeah, it can see around corners and it can cover a larger area.
Gotcha.
So it's good for like expansive spaces.
Okay.
And then emergency rope pulls.
Yeah.
Those are just a really accessible way for anyone to quickly stop machinery if there's an emergency.
So it's like a big...
So like if you had a conveyor belt, you could have rope pulls all along.
Gotcha.
Tracked key interlocks. Those are used to ensure a specific sequence of steps.
Okay.
So like you have to isolate the power before you can open a guard.
Gotcha.
And you do that with keys.
Right.
So you take the key out and you put it in the guard.
Gotcha.
Safety mats.
Yeah.
Those are just like presence sensing mats. So if you step on the mat, it triggers a stop.
Right.
So those are good for like around a particular machine.
Gotcha.
And make sure nobody's too close.
So construction product manufacturing.
Construction product.
This one seems to be all about...
This is a lot about...
continuous line production.
Yeah, continuous production lines.
So that must present its own set of challenges when it comes to trying to implement safety without...
because any stopping
everything
can be really costly.
Yeah.
So you need to find ways to integrate safety seamlessly.
Yeah.
And they emphasize here that it's not just about physical guards. Yeah. It's about the whole process.
Yeah.
So we see perimeter guarding again.
Perimeter guarding, yeah.
Hood-style point guarding.
Okay, what's a hood style?
Those are more localized. They're like little hoods that cover up a specific point of operation.
Just like a blade or something.
Or a pinch point.
Okay.
Without enclosing the whole machine.
Got it.
Area laser scanners.
Yeah.
Again.
Creating
zones.
Invisible zones.
Yeah.
Non-locking safety switches.
So those might be used where you need occasional access.
Yeah.
But you don't want to have to go through a full lockout.
Gotcha.
So it's a more controlled type of access.
And the range of hazards.
And the hazards they're trying to prevent here.
That they're trying to prevent here is really broad.
It's really broad, yeah.
It's things like electric shock, burns, ergonomics.
Yeah, ergonomics.
Striking from ejected materials, shear points.
Yeah.
Lots of stuff to think about.
A lot to consider.
Okay. Metal forming.
Metal forming.
This one is...
This is an age-old industry.
Yeah, an age-old, also evolving
industry.
Yeah.
They mentioned here an evolving workforce. Right, which I think is interesting.
Which I think it's interesting.
Yeah.
So we have...
So you have experienced workers.
People who have been...
Or the processes.
Doing it for a long time.
Yeah, they know the hazards.
Yeah.
But you also have new people coming in.
Right.
Who maybe have different expectations.
Different expectations around safety.
About safety, yeah.
Yeah.
And they might be more aware of like the newer technologies and standards.
So they're suggesting that we need to go beyond just the traditional...
Yeah, so it's not just about doing things the way they've always been done.
Yeah, the old school way of doing things.
More robust.
Yeah, more
systematic protection, especially for these complex operations.
And they're using all sorts of...
So you see things like...
different laser scanners.
Photo eyes, hydraulic safety valves, safety fencing.
Yeah, it's everything from the...
physical machine guarding.
Really old school.
Electronic safety devices.
The new high tech.
Right, and it really depends on a specific type of machine.
Yeah, it's very.
So you're talking about dumpers, hoppers, tippers, die cast machines.
Tailored.
Sand mixers, molding equipment, conveyors, robot packaging cells.
Yeah.
Even steel production transportation.
Yeah.
Payoffs, uncoilers, take-ups, recoilers, forming, sizing tube mills, H-coils, accumulators, coil slitters.
Hazards.
There's a lot going on.
Must be all over the place.
There is, yeah. And the hazards are going to be different depending on what you're...
What are some of the big ones they're trying to prevent?
Well, you know, crush injuries, pinch injuries, shear injuries.
Yeah.
Crush points, nip points.
Okay.
You know, all those things we've been talking about.
And then...
You see things like stack indicator lights.
Stack indicator lights. What's that?
Those are lights that tell you how high a stack of material is.
Gotcha.
So you don't overload.
Yeah.
Safety mats. And then they even mention metal top safety mats.
Oh, wow.
Which just shows you that...
That sounds heavy duty.
They need some really durable solutions in these environments.
So now let's talk about the food and beverage industry.
Okay. Food and beverage.
Because this one is interesting.
This is where...
Because now we're not just worried about worker safety.
Yeah.
We're also worried about...
hygiene.
And protecting the...
contamination. Huge concern.
Yeah. So how do they approach machine guarding in this sector?
Well, the guarding has to be designed with those things in mind.
Right.
So you're going to see materials that are easy to clean. corrosion resistant.
Yeah.
They're not going to harbor bacteria.
That makes sense.
They talk about consumer product factories, bottling and canning equipment, cappers, labelers, indexers, flame treaters.
So these are all high volumes.
Orienters, plastic chain conveyors, blow molding, injection molding, stamping equipment.
Environments.
Yeah, so they've got a lot going on.
Yeah, and so they're using things like...
wire
mesh, polycarbonate.
Point of operation guarding with wire mesh and polycarbonate.
Yeah.
Again, that visibility.
Yeah.
Is important.
So they can see what's happening.
Rotating shaft guards.
You don't
want anything getting tangled up in those rotating shafts.
Yeah.
Safety light curtains. Yeah. We've talked about those before.
Yeah.
And then they even mention the possibility of intrinsic safety or HAZLOC safety.
HAZLOC. So that's for...
Which is really important in environments where you have...
explosions and stuff.
Flammable ingredients or cleaning agents.
Right. So that makes sense.
So you need specialized equipment that won't create ignition sources.
Cause a spark. Yeah. Okay. And then the air...